So moving on to the next question from the subject process control, which is asked in test series 2 for IN is of 2 marks, which is from the topic tuning of controllers. So we'll go through the question. A double integrator plant given as k by s square, where feedback is unity, is to be compensated to achieve the damping ratio of 0.5. So we need to achieve a damping ratio of 0.5 and an undamped natural frequency, which is omega n as 5 radians per second. Which of the following compensator will do this? Will achieve a given zeta of 0.5 and natural frequency of 5 radians per second. So here with the given transfer function, we can clearly see that it is k by s square. So when I plot the pole zero diagram, when I draw the pole zero diagram, we can see clearly the two poles are located on imaginary axis. So the system is marginally stable. So we need to make it stable, and we have to make the zeta as 0.5 with omega n as 5 radians per second. So in order to achieve that, we need to have the compensator to be used in this kind of system is lead compensator, which will pull the poles to my left hand side. So basically we need to pull these poles to the left hand side to make zeta equal to 0.5 or the system to be stable from marginally stable system. So here we know the lead compensator transfer function generally is given as s plus z by s plus p, where the z should be less than p, and the value of alpha should be less than 1, the ratio of z by p should be less than 1. So if we can see the options, only option A will satisfy that. So these two are clearly rolled out from the general transfer function of a lead compensator. So from these two options, A or B, clearly z should be less than p, which is option A. So here the correct option is A.